Hello viewers, welcome to T online class. I am T Kumagbi. You can subscribe to my YouTube channel T online class, follow me on TikTok T online class, and of course on Facebook T online class and T Kumagbi. In today's video, we're learning chemistry, and the topic of our discussion is electrolysis part 2. Electrolysis part 2. In our previous video, we had learned about electrolysis. We defined electrolysis. Of course, we learned the meaning of some key terms in electrolysis, such as electrolytes, electrode, anode, cathode. Of course, we also learned about Faraday's first law of electrolysis. In today's video, we're learning Faraday's second law of electrolysis. Faraday's second law of electrolysis. Now, Faraday's second law of electrolysis states that when the same quantity of electricity is passed through different electrolytes, the relative number of moles of the element discharged are inversely proportional to the charges on the ions of the element. When the same quantity of electricity is passed through different electrolytes, the relative number of moles of the element discharged are inversely proportional to the charges on the ions of the element. That is a statement of Faraday's first and second law of electrolysis. Now, let's know what Faraday is. Faraday is the minimum quantity of electricity that is required to liberate 1 mole of a singly charged ion. The minimum quantity of electricity that is required to liberate 1 mole of a singly charged ion. Now, 1 Faraday is numerically equal to 96,500 coulomb. One Faraday is equal to 96,500 coulomb. Now, I define Faraday as the minimum quantity of electricity that is required to liberate 1 mole of a singly charged ion. Now, let's get to understand what I've said. Now, 1 Faraday, that means 1 Faraday will be required to liberate 1 mole of a singly charged ion for a monovalent element like sodium. Valent element like aluminium, 3 Faradays will be required to liberate 1 mole of electron in a trivalent element like aluminium. Now let's quickly let's step into the stoichiometry of electrolysis. Now we have a question on the board. The question says, calculate the mass of silver deposited when a current of 2.6 ampere is passed through a solution of silver salt for 70 minutes. We should take silver to be 108, 1 Faraday to be 96,500 coulomb. Now let's step into the solution right away. Now from this question, the current is equal to 2.6 ampere. From the question also, time is equal to 70 minutes. Time is equal to 70 minutes. Now we have to convert 70 minutes to seconds. Now how do we do that? By multiplying 70 times 60. By multiplying 70 minutes by 60 seconds, because 1 minute is equal to 60 seconds. So to convert 70 minutes to seconds, we have to multiply 70 by 60. 4,200 seconds. So we are done with that. Now the next thing we're going to do is to find the quantity of electricity. Now in our previous video, I had established that the quantity of electricity Q is equal to current in ampere times time. Current in ampere times time. We already have our value for current, which is 2.6 ampere. Of course, we have the value for time, which is 4,200 seconds. So we're going to multiply 2.6 ampere by 4,200 seconds to find the quantity of electricity. Now 2.6 ampere times 4200 seconds will give us 10,920 coulomb. So the quantity of electricity is 10,920 coulomb. Now what next are we going to do? Now the next thing is to write the cathodic half reaction for this kind of question. The cathodic half cell reaction for this kind of question. Now we're dealing with silver salt. The question says calculate the mass of silver deposited when a current of 2.6 ampere is passed through a solution of silver salt. Now we're calculating the mass of silver that will be deposited in a solution of silver salt. Now the cathodic half reaction for this kind of question will be as follows. Reaction for this kind of question, we have silver ion plus 1 electron. So now I had established that for a monovalent element, 1 Faraday is capable of, is required to liberate 1 mole of electron. So that means 1 Faraday is required to liberate 108 grams of silver. 1 Faraday is required to liberate 108 grams of silver. 1 Faraday is equal to 96,500 coulomb. So if 1 Faraday, which is equal to 96,500 coulomb, is required to liberate 108 grams of silver, then 10,920 coulomb will be required to liberate X gram of silver. How do we find X? X by simple cross multiplication of this. So if we cross multiply, X will be equal to So if you check this out using our calculator, we're going to have 12.22 grams. So our final answer is 12.22 grams. Therefore, 12.22 grams will be deposited. 12.22 grams will be deposited when a current of 2.6 amperes passed through a solution of silver salt for 70 minutes. That is our final answer, 12.22 grams. If you are interested in this kind of video, don't forget to like and share. Also subscribe to my YouTube channel, Must Online Class. Follow me on TikTok, Must Online Class, and of course on Facebook, Must Online Class, and then Must Take Agbe. Thank you for watching and God bless you. See you in the next video.